Good morning, everyone. Thanks for inviting us. So I'm Shaan Liu. Uh, we come from the Secure Fing AI Lab at Columbia University. So we are going to talk about the benchmarking Fing agents through open collaborations. And this is joined by our research assistants, Colin, Drizzle, Felix, Sarah, Kei, Yupeng, and Kevin. So this is our agenda. So in the first part, we'll talk about ongoing projects at Secure Fing AI Lab, including the Fing IL, FIN GBD multi-model roadmap. And in the second part, we are going to talk about the Fing agents with a few demos, including the Tutor agent presented by Jason, Search agent Fing IL agent by Kei, XBRL agent Sarah, ECC analyzer by Yupeng. And Kevin and Colin will present the leaderboard, including the evaluation process, the questions, the models, including the leaderboard, and then an overview for the whole projects. And then at the last, I will present our our collaborations through open source community, like with the support of Finnos. So in the first part, I will present the ongoing projects at Secure Fing AI Lab. So we start by building this framework for financial reinforcement learning. It's a three-layer projects. It's a three-layer structure. So in the middle, we have the deep reinforcement agents and connecting with different libraries, supporting different deep reinforcement algorithms, interacting with the market environments. So the agent observes the market represented as a state and then taking actions, execute it, execute those actions, and then receive the rewards. So for the market environments, we connect with historic data APIs, the Watson database, and Yahoo Finance, and we also connect with live trading APIs, different platforms, and also it supports simulations markets. And by having those agents connecting with the different market data, we showcase different applications, including stock trading, portfolio allocation, high frequency trading, crypto trading, and users can also define their own tasks. And then another project we're working on is the FIN GBD, Financial Generative Pretrained Transformers. Here's the framework. It's still taking the multiple layer structure here. So we start from the bottom, which is connecting with different data source, so including news, social media, finance, uh, the trends in index. And then by access those data, we fetch those data from different source, and then on going through a data processing layer, including like cleaning the data, feature engineering, tokenization them. And then we put those data into the large language models. You can call it in different ways. You can either do prompt engineering or directly using the API provided by different models like OpenAI API. And in the open source community, we have the Llama, we have DeepSeek model. Then by feeding in those financial data, we can even do fine tuning. So here we use the low rank adaptation, also like reinforcement learning as kind of fine tuning by checking the stock price, which can give the feedback rewards here. And then we showcase different tasks, including like sentiment analysis, summarization, question answering, and like it's also an interesting project is the NER, name entity recognition, sentiment analysis. On the top, we again show different applications. Can be robot advisor, can be a tutor, and more that we are building. So this is the overall framework that we have been working on over the past 2 years. Going forward from this FIN GBD projects, which is language centric at the beginning, and then we find that multimodal data is so important in finance. It can include text, number, charts, table, market data, image data, audio, video, and in the form of like earning conference call, monetary policy conferences, financial reports, financial news, market data, climate data, or in the schools, we have the exams. Students need to take in certificates. We envision that there are many applications in the form of financial agents. It can be powered by FinGPT, like search agent, tutor agent, robot advisor, compliance, auditing, credit scoring, report generation, trading, and local development. So those agents we believe they were involved into a agentic AI ecosystem enabled by essentially two parts. One is those open models supported by model openness framework, like the recent license, the Open MDW license, and there are also a lot of like agent protocols, including the MCP A2A, etc. By working on those multimodal financial models, in order to build those models, we find several components very important, like the benchmark data sets, building the model, the training data sets, and several very practical useful approaches can be fine-tuning and quantization those models, customize those models to user scenario, and retrieval augmented generation, make sure for accurate. And if in finance for banks, the federated learning approach is very important because it's a very important way for protecting the data privacy. There are also many important challenges that need to deal with. Essentially, we need to collect a lot of training data sets, and sometimes we probably use synthetic approaches. Yeah, then also they have the harmonization issues and so on. We also have in this unified framework to build financial agents powered by those uh, larger models or multimodal models. So here is an example that as a search agent as interface with the users, the search agent can fetch financial data from different sources. It can be like the SEC 10K filing in your local files. It can use MCP wrapper to access financial websites. For example, the Yahoo Finance website, also some like remote database, or even accessing a HTTP server. For example, you can access the Twitter, Wall Street Bet on Reddit. Okay, then.
My credit risk management exam is only 3 days away. During my review, I'm stuck in a hard problem and not sure where I should start. This makes me nervous. My first concern is that I can't fully understand various types of problems, so I'm unsure which formulas fit where. My second concern is that there are probably 28 people waiting for help in the officer's queue. I don't have the time to wait. I decided to look at old course materials, but couldn't find similar examples. The textbook and slides only offer generic examples to illustrate the formulas instead of thorough explanations on adapting these formulas to exam level questions. Many of my friends are in the same boat. We're all worried about not fully preparing for the exam and getting a poor grade, not because we don't want to learn, but because the support we need is either too expensive or it takes too much time. Take my friend Tommy, for example. He earned his master's degree in finance and is preparing for the CFA Part 1 exam to become a full time financial risk analyst. The exam is 4 months away, and it seems like he has plenty of time to prepare. However, the reality is Tommy is taking two part time positions just to cover his bills. Yet the CFA exam is crucial for landing his dream role. and answering the technical questions that come along with it. Even with the official study guide, he can't figure out how to build a study schedule or track his progress. Tutors cost at least $800 per topic, and the comprehensive video courses run more than 130 hours. What Tommy truly needs is an affordable assistant that can design a study plan according to his needs, keep him on track, and provide personalized tutoring whenever he gets stuck. Now, what if I had a tutor agent available whenever I need it at a cost the majority can afford? Instead of having to wait in the office hours queue, struggling to find relevant practice examples, or having to spend thousands of dollars on CFA prep courses, I can ask any question and get an immediate step by step explanation based on my strengths and weaknesses. The tutor agent pinpoints exactly what mistakes I'm making and shows precisely how to fix them. Supplemented by reasoning techniques, the tutor agent retrieves information from textbooks, past exams and mock exams, course notes, and online material to tutor me with relevant information. It can help in both previously mentioned scenarios, me studying for a tough credit risk management exam and my friend preparing for the CFA Part 1 exam. It doesn't just stop there. The tutor agent isn't limited to just answering questions. It can provide personalized practice problems and provide instant feedback. It breaks down dense, domain specific ideas into plain English. Most importantly, it stays by my side, whether the office hours queue is full or I'm studying on 2 a.m. the day of the test. Because the underlying large language model learns from every interaction each session, the tutor agent is smarter than the last. This is the future of democratized personalized learning. Imagine what a tutor agent can do.
Next, let me talk about the search agents. There are many professional financial websites such as Yahoo Finance and Bloomberg. In these websites, panels like market sidebar, news, and research contain lots of market data and information updating every moment. It can be overwhelming to navigate the financial websites and interpret this information without expertise. The personalized search agent can retrieve financial information from these websites and explain to the user timely and accurately. Could you let me share the screen to show a demo? Yes, recently there has been a drama between Musk and Trump. They clashed, and Tesla stock went on a roller coaster ride. A week ago, Musk criticized Trump's policies and they fired back at each other. But yesterday, both Musk and Trump softened their tongues. This is the news about their field, and it says Tesla stock jumps on a robotaxi momentum, Musk-Trump field cooling. When the user reads this article, they may have some questions. For example, what's the field and why is it cooling now? So the user can simply open the FIN GPT search agent and maybe go to the setting first and select the preferred model. And we can also add our preferred website here. It also has MCP mode and local rec, which I will show later. So based on this article, we may ask, for example, what's the field between Musk and Trump? What are some signals indicating that tensions between them are cooling? The search agent will scrape this web page, analyze the content, and answer. So here it answers that the field refers to a public war of words between Elon Musk and Donald Trump. And it also lists some signs about the temperature now. So Trump's constitutional tone and also his decision not to sell the Model S. And we may ask further questions to know more about this field. For example, list the timeline of this tension. And this time we can use the advanced ask. So the question is, list the timeline of this tension in June with important events and the performance of the Tesla stock. Advanced ask will search online for multiple websites instead of being limited to this webpage only. And the user can click sources to view what kind of websites the search agent is searching for. For example, here, it shows 3 sources, 3 links, and answered timeline in June. For example, in June 3rd, the event is that Elon Musk posts on X about Trump's bill. And in June 5, on June 5th, the stock plunges like 14%. And just yesterday, Elon Musk also posted a post about regretting some of the posts about Trump. In addition to web search, the search agent also supports local folder retrieval. Here, for example, we select a local folder. The test, here I just use the Tesla's 10Q report as an example. We specify this local folder, and then we select local reg. Then we may ask some questions about Tesla's 10Q report this year. For example, we can ask, how are Tesla's automotive sales in 2025 Q1 compared to last year? Then the search agent will retrieve the local folder and answer that in Q1, Tesla reported like around 13 billion compared to the 16 billion in Q1 2024. We can also double check in the 10Q report. Here it says that automotive sales in 2 years, Q1, and these figures, they are accurate. The last thing that I want to show is about MCP. So in the setting, we can select MCP mode. Here, we just show a very simple tool to show the proof of concept. For example, we can just say hello, and then the FIN GBD will return hello world. But the logic is that the search agent will initiate an MCP client process, and it will send a request to the server, and the server receives the request, call the tool, and returns hello world to the client. That's about the search agent. Another agent is trading agent. So generating alpha signals is very important for making informed decisions. As an individual investor without too many resources, imagine if we can ask Warren Buffett for value investing advice, consult a risk manager to identify any red flags about companies, or engage a sentiment analyst to interpret the tone of the market news, all timely and on demand. AI agents make this possible. These agents can form a professional investment team, which is personalized and accessible to any investor. For example, after using the search agent to retrieve financial information, users can further ask questions to extract sentiment scores. Based on the news about this Tesla again, the user can further ask questions, how is the market reacting to this news? Then the large model can interpret this article, analyze the sentiment, and assign a score and provide a rationale. And in this case, the large model gives a sentiment score of 4, meaning that the market is reacting positively. The investors are optimistic about Tesla's robotaxi and cooling political tensions. However, minor concerns or uncertainties may still remain in the short term, which make it not 5. It shows the capability of large models in extracting actionable signals from unstructured financial documents, which can then be integrated into trading agents. So after getting the sentiment score, we can integrate it into stock trading with reinforcement learning. RL is well suited for financial tasks because it can solve sequential decision-making problems and adapt to the dynamic financial markets. With RL, we can build an automated trading agent. As shown in this figure, the RL agent represents the investor, and the environment represents the financial market. The trading agent observes the current state of the market. For example, the account balance can be 50,000, the Tesla stock is 326, the number of holding shares is 30, and we can also include market data, market indicators, and also the large model generated sentiment score here. Then the agent takes a trading action based on the current state and its trading strategy. For example, it decides to buy 5 shares of Tesla stock. And the environment responds to this action by updating the state. After buying 5 shares, the account balance, stock price, shares, market indicators, and also sentiment score, they are updated to the next trading period. The environment also gives rise to a reward based on the agent's action and the new state. The reward can be the change of the total asset value, which is $12 in this case. The agent receives the reward and also take a new action in the new state. It learns from the trading experience to improve the trading strategies. We can use the FIN AI framework we discussed before to develop this automated trading agent. For example, to develop a Tesla trading agent, the user can select components on different layers in a plug-and-play manner. So in the applications, it's the stock trading scenario. And on the agent layer, we select these algorithms to develop a trading agent using, for example, ensemble methods. And on the market environment layer, we can use Tesla's historical data to construct the environment.
Now I will talk about the XBRL agent. So nearly 100% of public traded U.S. companies are required to file financial reports with the SEC using XBRL format. So you could think of it as a coding language for financial data. It tags items like revenue, expenses, assets, and in a consistent and machine-readable way. For example, on the left side is Apple's 10K filing submitted to the SEC. It is formatted in XML and filled with specialized tags and a complex taxonomy. While the structure enables regulatory processing, it's often overly complicated that even experienced professionals make critical mistakes. According to the Data Quality Committee, in just 2 weeks at the end of 2024, over 800 errors were found across 84 filings. And the example here is from a 10K. It is missing the required element, statement of cash flow abstract. These type of mistakes can lead to compliance risk, costly penalties, and repetitive effort. We can see significant potential in XBRL agent for enhancing compliance and consider it as a core motivation for our work. It saves time, reduces human errors, and make financial reports clearer for improving standardization in regulatory filings. More importantly, it accelerates prototype development for developers who can now build apps and tools using structured XBRL data without the need of deep expertise. XBRL agent tackles the challenge that general purpose agent cannot do. For a general purpose AI agent, it's not easy to handle the complexity of XBRL because it requires deep domain knowledge and experience. In other words, general purpose AI agent is still not yet have the same capabilities as finance professionals. Based on an evaluation of Finance Bench on various AI models, most models struggle with a low accuracy rate in finishing financial tasks. And this brings in that existing models are not yet ready for tasks in the financial domain, which is exactly why we need XBRL agent. The XBRL agent integrated with specialized tools designed specifically for analyzing XBRL documents. And there are two key tools, a retriever, which brings in accurate and up-to-date financial knowledge, and a calculator, which enhances the agent's ability to perform precise ratio calculation. Together, these tools allows the agent to extract relevant data from XBRL filings with greater accuracy and reliability.
Okay, now I'm going to the next agent, ECD Analyzer. The earnings conference call is an important information resource to know a company's financial condition. It's also a good channel for interaction between the company and the investors. Earnings conference call consists of the text presentation transcript and the audio record. Usually, the earnings conference call data is very long. Sometimes the transcript more than the 200 sentences, and the audio recording may over the 20 minutes. However, the investor may only want to know some part of the information from the earnings conference call, such as the major events or revenue for companies in past 3 months. Therefore, we can develop an agent to extract the key information from the earnings conference call data. So therefore, we design the ECD Analyzer agent, and here is the workflow. Firstly, we will capture the earning score transcript into the single sentence. Next, we will embedding each sentence into the vector database. We further collaborate with the business faculties to design a question bank, which includes many questions that investors typically ask. Each question will serve as a query to retrieve the important sentence from the vector database. We call it retrieval argumentation generation process. We also support the user-defined personal questions. Let me walk you through our ECC analyzer by using an example. We start with the raw earning call transcript, like this Tesla Q3 2024. The ECC analyzer firstly splits this transcribed sentence into the individual sentence for the further processing. Each sentence then gets the vectorized using the semantic embeddings and story in the vector database. When we want to extract the specific insight, we use the question bank of the 45 carefully crafted questions, like did the company pay the dividends or what's the plans for the cyber cap? Then the ECC analyzer will retrieve the relevant sentence and generate the final answers using the whole ECC analyzer agent pipelines. As you can see in the output of the right side, we get a response. For instance, identifying that the cyber cap is expected to reach volume production in 2026, and that the Tesla's autopilot shows a 10 times safety improvement over the US average. This automatic approach allows us to quickly extract the trading signals from the long earning call content, giving the investor the insights they need for the informed decision making. And here is our application case. We combine the ECC analyzer agent workflow with the multimodal deep learning models for the stock volatility prediction. We extract the key sentence from the earning score data as the FIN GBD features and fills them with the overall text and audio features of the earning score data for the volatility regression.
Meanwhile, AI agents have developed rapidly, but having these agents isn't enough. We need to separate their tasks and measure each skill in isolation, so we know what an agent is truly good at. This is exactly why we built Open Financial LLM Leaderboard. It's an open, continually updated benchmark that tests agent abilities across realistic financial scenarios. Let's dive into this specific capacity we focus on. For an agent to be reliable in production, it must be good at these skills. I will now give a few examples of how these skills matter with specific agents. i.e., we're referring to information extraction, is a key skill for a search agent we mentioned earlier. If it can't accurately pull entities and numbers from massive feelings, everything downstream breaks. And DM, referring to decision making, is crucial for trading agent. This agent strongly relies on its decision making logic. In the 4 examples listed here, agents are asked to label tasks as negative, positive, or neutral sentiment, showcasing a simple decision making capabilities. By separating these abilities and scoring them individually, industry and individuals can focus on the skills they truly care about and choose the most suitable models. Scoring models is crucial, so we need a standardized and open process. Models in zero-shot and few-shot settings, as well as those able to access external documents and APIs, are tested. For classification or choose tasks, the score is simply the accuracy of the answer the agent gives. For questions that require generative answer, we break the model's response into atomic keywords. The scores equals to keywords hit divided by total keywords. We then map all the scores to a unified 0 to 100 scale, making the leaderboard easy to read and understand. Beyond these ability scores, We also benchmark real-world tasks. This more intuitive approach tests models like students. CFA questions, referring to Chartered Financial Analyst exam, for example, is one of the tests we benchmarked. This score is more understandable. Industry and academia know what these test scores means, meaning making the AI agent comparable to a human professional assistant. If any parties have data sets they want to benchmark, feel free to contact us. We'd love to help.
So we built the Open Financial LLM Leaderboard because we want to evaluate LLM's multimodal capabilities in different financial tasks and explore the use cases of FIN agents. LLMs struggled with analyzing SEC filings and failed in CFA exams. After 18 months of development, we would like to see if LLMs are ready now. Existing works on leaderboard and evaluation pipelines consist of a large quantity of tasks and evaluation scores. This is because we need a rigorous, systematic, and measurable evaluation processes so that the financial industry can understand the strengths and the weaknesses of models. We go one step beyond, not just building another leaderboard, but creating practical AI agents that showcase the real financial use cases. We show how each model performs on the same task via a side-by-side comparison mode. Users can directly evaluate which models works best for their own scenarios and adapt the prototype agents into real business applications. We are integrating zero-knowledge proofs, ZKPs, into our evaluation pipeline. ZKPs give verifiable, privacy-preserving benchmarks by allowing models to prove they achieved a certain performance without exposing sensitive training data or model weights. This can protect both the user data and the model weights, which are considered as intellectual property. ZKP also makes the leaderboard more secure. It stops anyone from cheating by forcing models to prove their performance on hidden, secure datasets. For real-world financial AI agents, like those analyzing transactions or assessing risk, this means users get performance results that can be trusted with proof that they haven't had the leaderboard score. Now, here is a screenshot of our demo on Hugging Face. A row is a model, and a column is the average score of one category of task. As a starting point, currently we have an initial set of 7 categories that represent the fundamental skill financial AI needs: information extraction, textual analysis, question answering, text narration, risk management, forecasting, and decision making. We'll take this a step further. We are studying actual financial roles like analysis, risk managers, and traders to map out what tasks they do daily and what skills actually matter in their work. We collaborate with academia, the open source community, and industry to build better text datasets to reflect how finance professionals actually use information to make decisions. So here is another demo we built on Hugging Face. We bridge academic research and real-world financial workflows using XBRL. While most leaderboards test model on static datasets, we simulate how professionals actually interact with the complex financial data. So this demo shows multiple models processing the same XBRL file. The users can see how different models perform in parsing structured financial data. And again, we provide side-by-side comparisons for industry user where they can evaluate which models works for their real business applications. We are opening up the black box of financial task evaluation for LLM by demoing the AI agent and observing the performance of different models. This allows us to identify error patterns and use scenarios of financial LLM. We are studying actual financial use cases to leverage the power of financial LLMs. We welcome contributions from academia and industry.
Yeah, thanks for all those talented research assistants working with me in the past several years. And we have so many talented students at Columbia's platform. Besides that, we're also looking forward to collaboration with industry people and open source community. So we welcome like your contribution to our leaderboard to those Fin agents. So this is the reference flow for contributions curated by Finnos. So we want to identify the business use case, and then we trying to enrich and strengthen the evaluation the benchmark suites, identify the potential risks, and maybe enhance them by ZKP, blockchain, federal learning for data privacy or other security issues, mitigating the hallucination. Yeah, and continuous testing and updating those models and match with the real use case in the industry. Here's the example that even recently we got a new startup to contributing datasets to our work. So this startup actually collected a lot of data, a lot of chatbot conversations from the past year in the format of question and responses. So in total, they have over 2 million conversations in real world chatting scenario, and they have unique users over 15,000, and then breaking those conversations into question answer pairs, including over 3.5 million, and they include different LLM types, including GPT-4, ChatGPT, GPT 3.5, and OpenAI's O1 model, and for others. Yeah. So we also welcome other contributions of different question set, data sets, or use scenarios. And we want to leverage the like Finnos platform to do open collaborations so that we help our leaderboard and also those fin agents can serve as a reference for the financial industry. Okay, so thank you for your listening, and we at the Secure Fing AI Lab want to push forward the financial intelligence from the AI community to the financial industry.